Hello everyone and welcome to today's webinar on Predictive Analytics with Alteryx. I'm your host Sharon from Billigence, and I'll be walking you through some tools on Alteryx Designer which you could leverage on to conduct predictive analytics conveniently on your data. So let's get started with today's content. I'll just start to share my screen. So before we dive right into Alteryx, allow me to introduce Billigence, our company who transforms the way people work with data. We offer a blend of services which includes consultancy, technology, tools, and resources to guide your organization to transform into self-service, data-driven businesses. We're also proud to announce that we were awarded Alteryx's Partner of the Year in 2021. Alteryx is a leading platform for self-service data preparation, data blending, and advanced data analytics, enabling non-coders to perform advanced analytics conveniently and easily. The user-friendly working environment allows its users to easily find solutions to their business questions, which explains the reason why they have over 7,000 customers globally and was awarded Customer's Choice for Gartner's Peer Insights Customer's Choice in 2021. Today, we will be working on Alteryx Designer, Alteryx platform, which empowers data analysts to unlock insights to your data efficiently and easily so you could easily get answers to your business questions faster. It offers tools that don't just alter or clean data structures, but also perform analytics processes on your data within the same workflow. A typical process on Alteryx Designer would involve data input from various possible data types and connectors, and then going through data preparation and cleaning, enrichment, and analysis on your data before sharing your insights as you output your results through reports, analytics applications, files, and databases, or other visualization tools like Tableau. So just to give you a quick taste of how endless the possibilities are with Alteryx, this platform offers you over 50 tools to prepare, join, parse, investigate, or even transform your data with. This periodic table of tools you see on the screen gives you a quick glance of some of the tools and category of tools you could expect to see on Alteryx Designer. Living in a digital age today, businesses like yours are often working with huge volumes of data, which often has to be processed, interpreted, and reconfigured on a daily basis. Numbers are indeed useful, but less so than when they are presented in intuitive visualizations with predictions or suggestions to improve decision-making. Hence, businesses are often turning to advanced analytical processes such as descriptive, predictive, and prescriptive analytics. So Alteryx Designer offers a suite of such tools which aid with easy model building and deployment. Hence, in today's webinar, I will be demonstrating how these tools are inclusive for all users, showing you how easy it is for you to kickstart your journey with predictive analytics. So to introduce today's agenda, today's webinar will provide walkthroughs of Alteryx Designer's predictive tools for users of all experience levels. We will be looking at the assisted modeling tool for users who are new to predictive analytics, the Alteryx Predictive Tool Palette for users who are slightly more familiar with predictive analytics, and the Python and R tool within the Developer Tool Palette for the predictive analytics experts out there. So now that we've cleared the introductions for today's webinar, let's dive right into the predictive capabilities you will find on Alteryx Designer. For today's demonstration, we will be using a marketing data where we will envision ourselves as a marketing analyst from an educational institute. We are about to launch a marketing campaign and would like to understand or even know whether or not our customers will be responsive to the campaign. We will be utilizing 3 different data sets, which includes the course registration, the student account data, and contact data, which holds anonymized demographic data on our clients and past course registrations. So our objective today is to predict which customers are more likely to sign up for a course we are looking to market out. To those of you who are more experienced with predictive analytics, this analysis would fall under a classification problem where we pick whether a student will, yes, sign up for a course marketed to them, or no, they will not sign up for courses marketed to them. And this prediction is really useful in some cases as it makes the marketing efforts more targeted, being able to identify which customers are most likely to sign up for the courses when we reach out to them. This could even in turn increase success rates of marketing efforts and ensure a more efficient and effective approach when choosing customers to market our campaigns to. So this will be our workflow for today's demonstration when you are able to see different colored sections within the workflow, which will all symbolize the category of processes we will apply on our data. So without further ado, let's go right into the actual workflow on Alteryx Designer. Right, so if you're new to Alteryx Designer and you have never used or encountered this platform before, allow me to give you a quick introduction to the workspace available for you on Alteryx Designer. Upon opening the platform, you will be able to see 4 different sections, the tool palette here right above, the configuration window to your left over here, the canvas on the right side, this white space that you see my processes on, as well as the results window right below that. So all these are also annotated conveniently for you on the top left of each section. So in case you get lost, you could also refer to the titles right over here. So something unique you could already notice here on Alteryx Designer is that their tools have been categorized by color according to the different available functions. Input and output tools are always under the teal color section, as you can see over here. Data preparation tools are under the blue section over here. You also have join tools under the purple section, and so on and so forth, depending on the category of tools you would like to use. So similar to Tableau, Alteryx is as intuitive to use as using a tool would just require you to drag and drop the tool onto the canvas, and then execute a few more clicks to configure the tool. So for example, if I would like to input a data onto my workflow, I could simply drag and drop an input data tool onto my workflow. And here on my configuration window, you could see that I am given a choice to connect to a file or database. So with a few more clicks, just to select a file, let's say I would like to look for a file here. We can easily see, sorry, let me just locate my file real quick. Sorry, right over here. Right, so with a few clicks, we have inputted very quickly the data into our workflow. Now that it's, sorry, let me just let this process run on Designer for a quick bit. So with those few simple clicks and by just running the flow through this run button on the top right, you can very easily get your processes running on Alteryx Designer. So before we get any predictive tools involved, we would first need to prepare our data accordingly for them to run through the algorithms. So we would need to ensure a few things here that 1, our data is complete. 2, our data is clean, meaning no null values or trailing white spaces. And 3, our data is in the right format. So just to quickly introduce today's data sets to you, right over here, you could see that I have my accounts data here on top, where we have the demographic data on our anonymized customers. And then we have the course registration data set on the bottom right, where we have information on the courses and the registration data for these courses, as well as the context data here on the right. Let me just quickly scroll through it, which holds the contact details of our customers, which will be used at the end of the workflow. Since we will be predicting potential responses of our clients to the campaigns of our courses, we will first begin working with the accounts and course registration data on the left. As for general data preparation, which you could see within these containers, I have annotated in gray with the label general data prep. You could see that within these containers, we are here first cleaning our data by removing unnecessary columns, removing null values, or even correcting data types, as you can see through this datetime tool over here. You could also use formula tools to further modify your data with formulas, as you can see on the left, or filter tools to further filter and segregate the data we need for this analysis. As you can see over here, just as an example, I am filtering my accounts data to only include students of age 25 and within 60 years old. And before we get into the actual predictive analysis process here, we will now prepare some variables for our analysis. So knowing how my course registration data holds many courses, I would probably want to segregate this further to only analyze my top 30 courses first. So here in my inputs and outputs section where I select use this sample tool, I will first select my top 30 courses with the first n rows, selecting my n as 30. So this will help me filter out my first top 30 courses, as you can see below, by the number of accounts that is registered to it. And then we will also be using this text input tool to essentially input the course that we would like to predict on. So this text input tool allows the manual input of the course code so that we can easily analyze different courses and compare predicted results for each course. So once these two things are done, we will now very quickly set up a binary classification. So let me just go back to my slides. As a quick introduction, binary classification is a classification task in machine learning which has two class labels. Typically, binary classification tasks involve one class, that is the normal state, and another, which is the abnormal state. Examples of such situations would be for email analysis, where you have the class of a normal class where an email is not spam, and an abnormal class where an email is considered as spam. Another example that you would be more familiar with would be a medical analysis, where a normal state would consider a patient as healthy and an abnormal class would register a patient as unhealthy. So for our case, one class here involves a situation where a customer attends a course, which is our normal state, and another class which involves the situation where a customer does not attend a course, which is our abnormal state. And since binary classification cases are typically labeled 0 and 1, so typically these binary values, we will assign a class label of 1 for our normal state and a class label of 0 for our abnormal state. So you might be wondering why we are doing this. It's because we will be actually processing our data through one-hot encoding, which is a tool useful for machine learning on data which typically has no relationship to each other. So converting categorical variables into a form that machine learning is more familiar with, this will probably help the algorithms run with an improved prediction, ensuring that they will be predicted with a good model as much as possible. So this will all come together where the one-hot encode signifies that whether one has attended the class or not. After we input our target course and selecting our top 30 courses in these two steps here, we will now need to add a formula tool on the right, which indicates whether a customer has attended a course before. And then we will also add a dummy variable within this formula tool to help us later on with our one-hot encoding. So here, if I run a filter tool to see how this formula applies on an account, you can see that this user here has columns of course codes that she has attended, which will be labeled by the target variable here on use course code, and courses which she has not attended before, as compared to the target variable here with the course codes being displayed under the use course code column. So once this is ready, we will be using the cross-step tool to just flip this table over to take the courses as column headers now. So if you would like to see, our data previously looks like this, where we have the account ID in one column, we have the course codes in one column, as well as the dummy variable in one column. But after we use this cross-step tool to flip the table over, we will now have the account IDs all in one column, whereas the course codes are all in their own columns, representing the courses which each account has participated in with a value of 1. We also have the target column right at the end, which shows that this is the target course which corresponds to the target course we have inputted in the text input tool earlier on. And now with a data cleansing tool, we can very quickly populate the null cells with 0 to end off our build of our one hot and cold table. As you can see over here, the table is now complete with 1s and 0s. And now we're ready to pump them into the models. Right. Before we conduct our models, let's first pull in this create sample tool that I have on my workflow, which splits our data into a 60 to 30%. 60% of my data will go into the estimation sample data, and 30% of my data will go into the validation sample. I have also kept 10% of this data to use in holdout. Now, let's say when we're about to conduct our predictive models, you're in a situation where you have no idea which model to use or how to even configure the model to run your data. So here in Alteryx Designer, we have the assisted modeling tool, which could be found under the machine learning tool palette, which you could just drag and drop into the workflow. So once you drag this tool onto the canvas, run your flow and select Start Assisted Modeling. So once this window slowly starts to pop up, you will be able to see the steps that you will go through when you build the model. So here, if we go through step by step, we have the first step that asks you to select the target variable and the machine learning method you would like to go through. So here, you will be able to select the target variable and then choose the machine learning method that you would like to run through on your data. So let's say because we know that our current data requires us to do a classification model, we could simply select the classification selection and choose next. And now here in the next step, you could choose to do the automatic route, which the tool will automatically build the entire machine learning pipeline for you, or the step-by-step route, which helps you modify some configurations along the model build. So let's say if I were to choose step-by-step and click next. Let me just try to run this very quickly. Right, so step 3 will basically ask you to set your data types. Step 4 allows you to clean up missing values. And step 5 will give you the ability to select features. And step 6, last but not least, they will give you a selection of algorithms you can choose to select on your data. So once that's ready, you can actually see that they will come up with this leaderboard where you could now compare the performance of each algorithm that has been run on your data. So as you can see here, you are given a comparison between different prediction models, and you're also able to see the results that has come up from those prediction models run on your data. So here in the comparison tab, you can see the accuracy rates of each algorithm ran on your data, as well as an ROC chart provided to you below. So if you're more familiar with predictive analysis, you would know that this ROC curve will actually tell you the accuracy rate depending on the area under the curve. And if you would like to see the confusion matrix, this will be also available for you under the overview tab, where let's say if I were to choose different algorithms, you can now compare the confusion matrix that has been resulting from the data that you have. So let's say you're now satisfied with a few models that you would like to apply on your data set. You can just simply tick the boxes on the left side and choose to add the models and continue to workflow. Another feature that assisted modeling could provide to you is to also give you the option of exporting the code of the model built in Python in case you would like to further build on the model with a colleague who could be more knowledgeable on predicting modeling through code. So this feature could also provide you more flexibility when you configure your predictive model and also allow for collaboration between colleagues when the need arises. So here, if you would like to export this model into Python, from the three dots you can see from each predictive model, you have this choice to export model into Python. So what this does is it will actually provide a Python tool within your workflow, which you could then configure the models even further. So I apologize for the slight delay that's happening with the assisted modeling tool. But once this tool closes, we will be able to find the Python tool that will appear on our workflow that gives us the code of the random forest that I have selected up over here. Right, so once that has closed, now if I were to just scroll all the way down, sorry, and let me just delete this connection. Right, for the Python tool, I'll demonstrate this to you within my workflow as well. So just to save the time for this webinar, let me just run through the rest of the assisted modeling process I have in my workflow. So once we've actually added the model into our workflow, we can connect our validation data set that we have set previously from our create samples tool here from the V-anchor. We could just drag this into the predict tools we have on our workflow. As you can see, if you were to connect it to other data preparation tools on Alteryx itself, let me just quickly run the workflow. You will then be able to calculate out the true positive, true negative, false positive, and false negative values, which will then bring you to the accuracy, precision, and recall rates of this model. And so that's how you could use the assisted modeling tool on Alteryx to build predictive models. So now let's say you're more knowledgeable about predictive analytics and you would like to, know the models available out there when you conduct predictive analytics. But probably you do not know how to use coding languages like Python to build your model. So Alteryx Designer actually has a suite of tools which could help you build these predictive models without having to code a single line. So here, as you can see on my tool palette, you will be able to find the predictive tool palettes where you could find models like the decision tree, the forest model, linear, and logistics regression. So in our case, let's say that we do know that we want to build a classification model, and we know that there's an algorithm called the decision tree, which we could use. Conveniently, Alteryx Designer does have this tool. So once we drag and drop this tool into the workflow, with a simple few more clicks, you could now configure the decision tree to run on our data. So as you can see here, you will just need to select your target variable and select your predictor variables. So let's say we have all the variables you could see over here. You could choose to include or exclude some data as you would like. And once you run the workflow, you will now be able to see the results of this workflow within Alteryx itself. The results will come out through two anchors, the R anchor and the I anchor, where the R anchor gives you a statistical report on the predictive model that has been run on your data. The I anchor here provides an interactive report of the results of the model. So if you'd like a more succinct information on the model results, you could just simply look at the interactive anchor output to understand the results of your model. So here within this report, which I will show you later on, within this webinar, you could simply see the accuracy, precision, and recall rates of the model very conveniently, and can also find an interactive confusion matrix, which could help you understand the results of your model. So once you're satisfied with the model that you have built, you will now also use the score tool here to assess your model's performance on the validation set of your data. So similar to what we did in the predict tool above with the assisted modeling section, we will connect the validation data to the M anchor of this score tool, which will then allow you to do some data preparation steps on your data to calculate the true positive, true negative, false positive, and false negative values, which will then lead you to the accuracy, precision, and recall rate of your data as well. Do this process with other predictive tools available from the suite of predictive tools you see on top, such as the boosted model, forest model, or linear and logistic regression, depending on your target variable. So last but not least, if you're very well versed with predictive analytics and already have a model in mind, all coded out outside Alteryx, you could easily import your code into the workflow using the Python or R tools from the developer tool palette. So here, let me just scroll through the side. Within the developer tool palette, you will be able to find tools like Python and R, where you could easily import your code in. So as you can see in my configuration window, the Python tool provides you a interface, which is like Jupyter Notebook, which you could easily just chuck in your code into this tool. And the R tool allows you to easily import your scripts to their code editor as well. So you should be more proficient in both Python and R before using these tools. So depending on what your code entails, you can then proceed to combine your Python code with other Alteryx tools, as you can see here, to complete your analysis on your data and the model you have built. So once you're satisfied with the models that you have chosen on Alteryx Designer, or models depending on the state of your workflow, you could be in a situation when you are sure of only one model to conduct your predictive analysis. Or you could be like me here, where you have a workflow with multiple predictive models built from my dataset. The purpose of doing so is giving you the ability to compare models to choose the one that is best suited for your data. So since we're aiming for a model that gives us the best outcome for our data, so let's say in our case, we have the decision tree as our selection for our dataset, we can now also work it up with our holdout set that we have set out in our create samples tools earlier on to connect back to our score tool. As you can see here, I have connected my holdout set to my score tool to now find the predicted score again and then filter out accounts who have not taken the target course but should. Then once we have this result ready, we can connect it back to the context data, which I have shown earlier on down over here, where we can then get the accounts which we should target in our next marketing campaign. So there you have it with this list of accounts from the context data set. These accounts in this browse tool, which I will again show you at the end of this webinar, are the contacts which we should then decide to market on depending on the predictive model we have run on our dataset. And so that is how we could actually conduct predictive analytics very conveniently on Alteryx Designer. So as a tool recap, allow me again to go through the tools we met today, which helped us build the predictive models conveniently on Alteryx Designer. So we had seen the assisted modeling tool earlier today, which provides an assisted build for the machine learning models. This tool provides you a guided step-by-step or automated process to build your model and also allow you to compare the algorithms before choosing the best option for your analysis. Also, as a tip, the code for the model is also available for export onto the workflow. So this tool caters to users who are unfamiliar with predictive analytics and probably have no idea where to start. We had also seen the suite of predictive tools available on Alteryx, which ranges from classification to regression models, as well as traditional or modern statistical learning methods. The suite, in fact, also includes tools for model comparison and hypothesis testing. These tools are more for users who have an idea of what predictive analytics should be like, but have probably no experience in building that model on their own. Last but not least, we have the Python or R tool, which allows users to import your custom models which you have built outside Designer, but you would probably like to use on your dataset within your current workflow. This allows you to work on your data on a single platform so that you don't just clean and prepare your data on Designer, but also have the ability to analyze, find insights, run a predictive model through your data, and then compile your results into a report all on one platform. Do note that this tool would probably be best for those who are experienced with predictive analytics and are more used to building models through code. And in case you wanted to go further with the capabilities of Alteryx Designer, after completing your analysis, you could also leverage on Alteryx's reporting tools to create interactive charts from your insights or even compile them all into a report for your quarterly reporting or end of year reports like the one you see on the right. It is also as simple as dragging and dropping the tools onto the canvas and configuring the settings as per your desires. So as you can see in the report that is presented on the right, this is a sample report where you could see that from the prediction models, we have predicted a few users and even have charts that show you the demographic breakdown of each category, let's say by age, marital status, education type, or job type, and also the list of accounts we should be targeting for our next marketing campaign. So with that, I have come to the end of today's demonstration and presentation on Alteryx's predictive analytics capabilities, and I will be now providing some time if anyone has any questions pertaining to today's topic. Please feel free to drop your questions in the chat box and I will attend to them shortly. All right, so I have a question here that asks, I can't seem to access the assisted modeling tool on my Alteryx Designer. What is wrong? So thank you for your question, Lucy. So basically, for the assisted modeling tool, which you could find within the machine learning tool palette, is actually available on a different license from the Alteryx Designer license that you would probably have by now. So if you would need any help with regards to this licensing issue, you could probably reach out to Alteryx to help you out with that, or you could also reach out to us if you would like to know more about the Intelligence Suite and also probably fix that issue of the machine learning tools not being available to you. So thank you for that question, and I hope that answers your question. Right, so I have another question here which asks if you could export the reports created by the predictive tools outside of Alteryx. So thank you for that question as well. So if you were to see the predictive tools that you have seen earlier on from the R and I anchor that I have mentioned a while ago, you could also leverage on the reporting tools within Alteryx, let's say the layout or render tool that can help you export these reports out of the workflow for you for your reporting as well. So like the report that I have included in the presentation slide, you could also include such reports onto your compiled report and then conveniently use them for other reporting that you have required for your business requirements. So thank you for that question. I hope that answered your question as well. Let me see if I can also get this to run. All right, so last question I see here. I have one that asks me, how do I determine or know which model I should use for my data? So thank you for your question about this. To simply answer your question, model selection will basically come down to the nature of your data that you have, that you want to work with, and the nature of the analysis that you would like to conduct on your data. So factors such as the distribution of your data will decide if you should use, let's say, a logistics regression over a linear regression model. And another example would be if you know whether your data requires some time series analysis done on it, then you could choose to use predictive models such as the ARIMA model or something like the ETS model as well. So my final example would probably also be if you would like to solve a classification problem, which we have seen earlier in today's webinar. If you have such a classification problem that possibly involves more than two cases, so this situation would probably be unsuitable for predictive models like logistic regression, which purpose is to basically solve a binary classification like we had seen earlier in our webinar. So depending on the use case that you have on your data, then you can pick a few models here, which I could probably just very quickly list out a few for you. You have the classification model, which is considered the simplest model. So this model actually helps you categorize data for simple and direct query response. So an example of this use case would be to probably address the question of whether this client will convert as a client for your company or not. So this is the sort of classification problem that you could conduct such classification models on your data on. You also have the clustering model, which nests data together by common attributes. So you cluster them into different groups. And so it works by grouping things which have shared characteristics together. And then you plan strategies for each group at a larger scale. So an example of this situation is basically to determine the credit risk, let's say for the clients you have, based on what other people have did in the past. So this is a clustering example that you could apply clustering models on. And then you have another model called the forecast model. So this is actually a very popular model that a lot of people actually look for, where it works on anything with a numerical value based on historical data. And then you can answer questions like how much lettuce someone should order next week, like how much lettuce a restaurant should order next week for their pool of customers, or how many calls a customer support agent should be able to handle per week. So this is an example of forecast model use cases. You also have the regression model, which helps you, provides you the function to describe the relationship between one or more independent variables and the response dependent or target variable. And so this would include examples of the relationship between the height and weight of individuals, which could be described by a linear regression model. You also have the time series model, which evaluates a sequence of data points based on time. So an example of this would be like the number of stroke patients you could expect depending on the last, the data of such stroke patients admitted into the hospital over the last 4 months. So this is an example of the time series model. So it really depends on the use case you have in your data and the type of analysis you would like to conduct on that set data set as well. So I hope that answers your question as well. All right, so if there aren't any more questions, I would like to thank everybody for their time today in joining me on this webinar about the predictive capabilities that Alteryx Designer has to offer. If you are interested in this platform or would like to speak to us to understand how you could leverage on such Alteryx features on your own data, or even look for a trial for Alteryx Designer as well, please feel free to reach out to us at billigence.com. And once again, I am Sharon from Billigence Singapore. Thank you for your time today, and please stay safe. Thank you.